More than 100 million people live within 1 meter of sea level. And if we have the type of sea level rise that's projected for the end of this century, that means hundreds of millions of people have to move, and they may not have the resources to do so.
But Jason has a mind-blowing plan to stop the melt. Cover Greenland's glaciers with sun-reflecting blankets. But the blankets must be more than reflective. They've got to be super tough to survive the hostile conditions that exist here. In winter, temperatures average -45 degrees Celsius, and 160 km/h winds can chill temperatures down to -70. Finding the right material for the blankets is crucial, but Jennifer Languel, the team's eco-engineer, thinks she has a solution. Hemp, the world's strongest natural fiber.
Hemp, historically, is a really versatile material. It's reflective and it's extremely strong. I also like the fact that it's natural.
Jennifer needs to conduct a test to see if hemp is strong enough to survive the brutal Greenland climate. She'll put the hemp blanket through a simulated hurricane-force ice storm, designed to mimic the worst conditions possible in Greenland. Kevin O'Leary, in charge of logistics, has arrived to see how well the hemp holds up to Arctic conditions.
So if it survives this test and it's still sitting here pretty and reflective, we're done.
Turn over the wind machine!
After being battered by 160 km/h winds, the hemp blanket has been ripped to shreds.
It's a problem.
That is a disaster.
This is useless, like a wet rag in a shower.
We just need a stronger fabric.
It's clear hemp isn't tough enough to survive in Greenland's frozen environment. But there's another option. Jennifer and Jason have learned of a project in Austria. The effects of global warming are undeniable in Austria's Alps. Experts estimate the glaciers here have lost as much as 60% of their volume in the last 150 years.
Several years ago, the local people were noticing their glaciers going away. And that has devastating implications to their economies because they depend on the tourism and the skiing.
In 2003, scientists at the University of Innsbruck found a way to fight back.
In this desperate situation, the Austrians decided to actually put reflective covers on their glaciers to slow down the melt.
The cover, still in use today, is a rugged polypropylene called SP340. It's resistant to microbes and constructed in a bird's nest pattern for added strength.
I think this material's incredible. We can actually use this material to preserve glaciers worldwide.
The blanket fights the melt with a 1-2 punch. The super white surface reflects sunlight without conducting heat to the ice below. Simultaneously, the material traps the freezing air below, slowing melting. The covers successfully used in Austria now give Jason's experiment a head start. But only if this high-tech fabric can take the brutal beating awaiting it in Greenland. The team is ready to put the polypropylene blanket through the rigorous wind machine test. They know it can survive the Alps. Now they'll see if it can survive the Arctic.
Start up your machine. Bring it up to 100 miles an hour. ice, crank up the conveyor. Faster on the wind. Bring it up to 150.
That's tough stuff.
The polypropylene stands up to the test limit of 240 kilometers per hour.
Surviving the Arctic hurricane.
It passed the test.
Nothing failed on that. That is awesome.
Wow.
The polypropylene beats the hemp, hands down.
Well, there are a couple of things I find exciting about this material that we found is that while it was designed for one thing, we can actually apply it in this geoengineering experiment. We can make an experiment in Greenland, a giant laboratory, and do a larger scale experiment and find out, is this a viable approach to stopping the melt?
In a matter of days, Jennifer has assembled almost 2,000 square meters of SP340 fabric in Austria. After weeks of planning, it's time for the main experiment. The team flies to Greenland, along with their cargo of ice blankets and supplies. They touch down on the rocky edge of the ice cap. This is Kangerlussuaq, one of the world's most remote outposts. Jason's test site for the experiment is just 160 kilometers from here, but it might as well be on the moon. Kevin O'Leary, the team's logistics expert, has been working for weeks on how best to get his people and equipment onto the glacier.
For hundreds of years, people have used dog sleds to get between each other's places. I can't use dog sleds. They're useless for me. Everything I need is there, and all of it has to get there onto the glacier.
Although the team has planned a scaled-down blanket test, the sheer bulk of materials and equipment needed has mushroomed in the past 2 weeks.
The first time it really sunk in that this was a hugely epic task was seeing the tons of gear we had to bring up here.
Jason Box's dream to save the world's glaciers is turning into a logistical nightmare.
We've got to take with us 7 tents, drills, solar batteries, rope, and not to mention nearly 4 tons of blankets.
A lot of science equipment, loads of food in case the weather conditions get really bad.
Kevin thought he had the logistics nailed. The gear would be moved to the glacier by a twin-engine helicopter. But even this large workhorse chopper can't hold the mountain of gear. Kevin now needs a whole fleet of helicopters, and that creates a difficult dilemma.
Transporting these really heavy loads by helicopter to remote locations means we're making more carbon dioxide. We're adding to the carbon footprint. Is this the way we're going to save the planet? I have to figure out if this is even going to work.
The problem has exposed a huge issue. The long-term benefits of covering Greenland's ice cap in plastic may be cancelled out by the huge emissions of greenhouse gases produced in manufacturing the blankets themselves and the carbon dioxide from the fleets of helicopters needed to move the blankets to the glaciers. This geoengineering strategy may not work.
We've got to limit the carbon footprint of this experiment, so we've decided to limit the number of round-trip helicopter flights to just 5.
Kevin decides to send half the number of reflective blankets, enough to cover 2 acres of ice instead of 4. Even that load is too big for the chopper's cargo hold. But Kevin and the pilots come up with a solution.
How do we get these things up? We put them in a sling. You ever done that before? It finally occurred to me, these are Sikorsky S-61s. The Army uses these to carry tanks underneath them. They simply put them in a sling. We're going to do exactly the same thing with the blankets.
Jason calculates that using 2 acres of blankets will provide enough data to test his theory. In fact, even his future plan to save Greenland's glaciers calls for covering only a portion of the ice sheet.